Okay, part 2, radicals. We had to do this in 2 parts because the video was a little too long to post to YouTube. So in part 2, we looked at 2 topics, simplifying radicals and adding and subtracting radicals. So we did very well on that quiz. We have those 2 methods that we can choose from. Either we make a factor tree and we then circle groups depending on the index, or we look for that largest perfect square or largest perfect cube and rewrite it as 2 separate kind of radicals and go from there. So in this first set of practice problems, we just want to simplify. So that just means that it's not in simplest form. There's a perfect square or a perfect cube hidden inside our radical. So in practice problem number 1, we have the square root of 24. So I decided to rewrite it as 4 times 6, or the square root of 4 times the square root of 6. The square root of 4 is just the number 2, and then we carry down the square root 6 because there's nothing we can do to simplify that. In problem number 2, it's very similar. It's the cube root of 24. So now I'm looking for perfect cubes. So I decided to rewrite it as the cube root of 8 times the cube root of 3. The cube root of 8 is just the number 2, and then we carry down that cube root of 3. Remember to always carry down that index with you as well. If there's nothing in that index spot, we assume we have an index of 2. 3 and 4 look very similar. We've also added variables in there as well. In practice problem number 3, we see we have the square root of 54, x to the 3rd, y to the 4th. So I decided to rewrite this as the square root of 6 times 9, and then I expanded and wrote out 3 x's and 4 y's. What we notice here is that I'm looking for groups of 2, or those perfect kind of squares. So for every highlighting, I'm taking one of those kind of groupings out to help me. What I'm looking at is 3x y times y, and then whatever I didn't highlight is staying underneath the radical, so 6x. And just to clean that up, y times y, we would make y squared. So we're looking at 3xy squared, the square root of 6x. Very similar in problem number 4, but now we're looking for perfect cubes. So instead of 6 and 9, I'm using 2 and 27. What I notice here is that I'm highlighting groups of 3 instead of groups of 2. For every highlighting of the variables, I'm taking one outside the radical. Here I'm looking at a final answer of 3xy, the cube root of 2y. So once again, don't drop that index, and whatever we didn't highlight stays underneath that radical sign. The last topic we're looking at is adding and subtracting radicals. So remember, we always want to see if we can simplify the radical first, just like we did in those last 4 practice problems. We can only add and subtract radicals if they have the same index and the same radicand, which is the number underneath the radical sign. They need to have both conditions met. If they do, then all we're going to do is add the coefficients, the numbers in front of the radicals, and we keep the radicand exactly the same. So on practice problem, this should be practice problem number 5, we're already in simplest form. We have 3 square root 2 plus 4 square root 2. All we're going to do is add the 3 and the 4 together, and we carry down that radicand the same way. So we're looking at an answer of 7 square root 2. We don't change what's underneath the radicand at all. In the next 2 practice problems, we're going to have to do some simplifying because we can see that there's a perfect square inside of 20 and inside of 45. So the first thing that I did is I rewrote it as 4 times 5 and 9 times 5. I'm going to take the square root of 4, which is 2, and I'm going to multiply it to the number that's already there. So we're multiplying it to the 4, and we're going to multiply the 3 times the 2. So my next line is 4 times 2, the square root of 5, minus 2 times 3, the square root of 5. Now I'm looking at 8 square root of 5 minus 6 square root of 5. Notice it's now very similar to that previous problem. They have the same index of 2 and the same radicand of 5. All I'm doing is 8 minus 6, and I carry down to get 2 square root of 5. In this very last practice problem, we have some simplifying to do, but then we also need to be aware that that last term is a square root compared to the cube roots of the first 2 ones. So the first thing that I'm looking at is simplifying. So I rewrote my next line as the cube root of 2 times 8 plus 4, the cube root of 2 was already in simplest terms, minus the square root of 2 times 4. When I rewrite my next line, I'm looking at 2 the cube root of 2 plus 4 the cube root of 2 minus 2 square root of 2. I can only add the first 2 terms together because this last one does not have the same index. So my final answer is going to be 6 the cube root of 2 minus 2 the minus 2 the square root of 2. I can't go any further than that. So hopefully we feel pretty confident about our radical section, the most recent thing that we did. I'm working on making like an index card for us to use as well, and then obviously we'll have this resource available for us during the MCA, and I'll post the key once everyone finishes the Edpuzzle as well. So I will let you know when I have that index card ready for us so that you can use that as well.